Welcome to qnawire.
Draw all of the possible conformations for the molecule that is shown over here. Just a little reminder of what is going to be able to happen is that whenever we do a Newman projection, the atom that is going to be a dot is the one that we're looking at. So, for example, in this case, our eye is going to be looking into carbon 2, and the possible configurations can be, in this case, for example, an staggered configuration. In this case, I'm not going to put all of the labels that we can have. And we can also have, let me put it now like this, an eclipse configuration. Within these configurations, we can have interactions that are called gauge interactions, which are the ones in between sections of the molecule that are going to be 60 degrees from each other. And we are also going to have anti-interactions, which come from, I'm going to use this guy and this guy as example, which are sections of the molecules whose substituents are on opposite sides. Normally, we don't draw this interaction for hydrogen atoms, we just do it for substituents because the steric effect is larger for carbon atoms than for hydrogen atoms. Consider the volume that would imply having a CH3 compared to the volume that would imply having an hydrogen atom. So with this small review, we can start doing this for our molecule at hand. Remember, carbon 2 is going to be the one on the dot. So over here, we're going to have CH3, CH3, and CH3. And for the second one, what we can do is, let's begin by putting the CH3 on this position. So CH3, hydrogen, and hydrogen. So this one is going to be a staggered configuration, staggered with gauge interactions. Now we're going to rotate this 60 degrees towards the left, and what we're going to have is an eclipse configuration. So let's draw this again. For simplicity, I'm going to rotate the carbon atoms that are on the front. So what this is going to look like is the CH3 now is going over here, CH3, 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 and we're going to keep the atoms on the carbon tree on the same positions, CH3, hydrogen, and hydrogen. So this corresponds to eclipse configuration. Let's rotate again the carbon 2 atom 60 degrees towards the left. And now what we're going to get is essentially the same configuration as the first one. So now, after rotation of 60 degrees, we're going to get CH3, CH3, and CH3. And from the back, we're going to put everything on the same position. CH3, hydrogen, and hydrogen. Okay, so now as you notice, the staggered configuration is going to be repeating. So just to make the drawing a little bit more clear that we're rotating stuff, let's rotate the atom on the back instead of the one in the front. So I'm going to do this also for this one. This is just for making the visual super clear of what is going on, but it is still going to be correct. Okay, so don't worry too much about that. So I'm going to keep the one on the front on the same position, and then I'm going to rotate the one on the back. CH3, CH3. So if we rotate the one on the back, now we're going to get our CH3 over here. CH3, we're going to have our hydrogen over here, and our hydrogen also over here. Now for the next one, Again, we're going to keep the ones on the front the same. CH3, CH3, CH3. And the ones that are coming from the back, we'll put them in red just to make it better for visualization. CH3, hydrogen, hydrogen. This is also going to be an staggered configuration with gauge interaction. We're also going to have, at the same time as the gauge interaction, we're going to have an anti-interaction coming from both of the sides over here. So this is going to be anti as well. Okay. Same thing goes for this one. An anti on that position. Now, let's rotate again the ones. Let's rotate again the ones on the back. Now, this guy is going to be over here, CH3, hydrogen, and hydrogen. This is going to be an eclipse configuration. Rotation again of 60 degrees. CH3, CH3, CH3. And now the CH3 is going to be on this position right below. CH3, hydrogen, and hydrogen. So we're going to have an anti-interaction between this guy and this guy. These are anti to each other. And we're going to have gauge interactions. Well, in red, just to keep everything as was. Gauge interaction in between the methyl groups on both sides. And the final is another eclipse configuration. Remember, keeping the same one on the front. And now our CH3 would be over here. CH3, hydrogen, oops, and hydrogen. Well, around here. And this is an eclipse configuration. So these are all of the possible Newman conformations that we can have. Hopefully with the initial explanation, you're going to be able to do the drawings way faster than I did, because it's faster to do these drawings on a regular notebook than in a pen tablet. So with that, it would be all. Thank you very much and have a good one.